Objective 2. Impact of the starting value of the vertical axis of a bar graph or time series plot. Example, the percentages of commuters who walk to work are described by the bar graphs below for the 5 cities with the highest percentages. So if we take a look at our left, the top 5 cities of commuters who walk, there's your 5 cities. And there's your percent. It's starting at 0 and it's going in increments of 3. And on this side, again, we have the same cities, but we're starting at the value of 8, going to 15 in increments of 1. So the first question states that if Boston's mayor's office wants to convince people that the percentage of commuters who walk is much higher in its city than in any other city, which bar graph would it display? And then we'd explain. Well, Boston's mayor's office would use the bar graph with the vertical axis starting at 8%, because the scaling on the vertical axis increases by a smaller amount than any other graph. This bar graph emphasizes the differences in percentages and seems to show that the percentage of commuters who walk to work in Boston is greater than that of the other cities. And again, here you have your increments of 1. In part B, it states that if San Francisco's mayor's office wants to promote its city as being almost as much of a walking commuter city as Washington, which bar graph would it display and explain? Well, San Francisco mayor's office would use the bar graph with the vertical axis starting at 0%, because the scaling on the vertical axis increases by a larger amount than any other graph. This bar graph de-emphasizes the differences in percentages and seems to show San Francisco's percentages of walking commuters to be similar to Washington. In part C, from which bar graph are you more likely to better estimate the percentage for San Francisco? Explain and then estimate the percent. Now, if we take a look at the bar graphs, here again are increments in 3. This is in increments of 1 as a percent. So, because we have increments of 1, it gives you a closer look of the vertical axis, which gives you a better sort of visual of how to be able to figure out what that percentage is. So the bar graph with the vertical axis, it's starting at 8%, gives a better estimate of the percentage of walking commuters. Again, the graph is more zoomed in on a vertical axis. Now we want to be able to estimate what that percentage could be. So if we take a look at San Francisco's here and then go towards the vertical axis, we can see it's like around 9.9. And so therefore, we can roughly say that the estimate percentage is 9.9%. Next question, part D. First, we want to estimate the percentage of commuters who will walk to work for Boston and New York. If there are approximately 3.64 million commuters in New York City and 0.36 million commuters in Boston, estimate the number of commuters who will walk to work. Which pair of results, the percentage or number, would New York City's mayor's office highlight if it wants to promote its city as being more of a walking commuter city than Boston? Well, we need to first take a look at the percentage for Boston if we want to first figure that out. So if we take a look at the percentage for Boston, we can see up here that it represents 15%. So let's go down here, and what we're going to do is for Boston has 15% of commuters walking for a total of, well, 15% is a decimal of 0.15. We're going to multiply it by the 0.36 million commuters in Boston, which gives us 0.054 million. Now, if we want to convert this into a value, we can multiply this 0.054 times a million to get this value. Let's take a look at the calculator here. Okay, if we take 0.15 and then we multiply it by 0.36, that gives us 0.054, but that's in millions. So now we want to multiply that by 1 million, and we get 54,000. So that's 54,000 walking commuters for Boston. Next, what we want to do is now figure out New York City. So if we come back up here and we take a look at New York City, what is the percent for New York City? Well, it's approximately about 10.3%. So New York City has 10.3% of commuters walking for a total of, converting 10.3% to 0.103, and we're going to multiply it by 3.64 million commuters. So let's go ahead and do this on the calculator. So we're going to take 0.103, we multiply that by 3.64, and that gives us, if we round that, it gives us around 0.375. So rounding it to 3 decimal places. So we're going to take 0.375, and then we're going to multiply that by 1 million. And that gives us 375,000 walking commuters. So New York City would highlight the number of walking commuters because we have more for New York City walking commuters than we have for Boston. Next example. Freshman tuitions in thousands of dollars at Penn State Harrisburg are described by the time series plots given below for various years, where the starting year of each academic year is shown in the horizontal axis. So here's our horizontal axis for this first graph on the left. It goes from 2008 all the way to 2012. And if you look at the thousands of dollars, this goes in increments of 3. From 0 to 3, 3 to 6, 6 to 9, and so on. On the right side, again, we have the same years. And this increment is going starting at 10.5, going to 11. So it's in increments of 0.5 thousands of dollars. So for part A, it states that if a college wants to de-emphasize how much its tuition has increased, which time series plot would it want to display? And explain. Well, if the college wants to de-emphasize how much its tuition has increased, it would use the time series plot with the vertical axis that's starting at 0,000. The differences between the tuitions are de-emphasized because the scaling increases by a larger amount than in the other time series plot. So you can see here it doesn't look like it's increasing as much from 2008 to 2009. But if you look here, let's go ahead and highlight that. Okay, if you look from 2008 to 2009, it doesn't look like it's increasing as much. If you look from here, 2008 to 2009, it's increasing a little bit more because of the scaling of the graph. If we take a look at 2009 to 2010, on the left side, you can see again it's increasing, but over here, 2009 to 2010 is increasing a little bit more. For part B, it says, from which time series plot can you better estimate the tuition in 2011? And what is that tuition? Well, a better estimate of tuition in 2011 comes from the time series plot with the vertical axis starting at 10.5 thousand because they're in increments of 0.5. It's easier to estimate the tuition because the scaling on the vertical axis increases by a smaller amount than in the other time series plot. So now if we want to estimate what that number looks like, and again we're dealing with an estimation. Okay, so for 2011, go across here. So that's about 12.8. And now keep in mind that it's 12.8 in thousands. So if we take 12.8 and multiply that by 1,000, then we get 12,000 $12,800, which would be the answer here. And again, a rough estimate. So the 2011 tuition is approximately $12,800. Part C, it says, from which year to the next did the tuition change the most, and estimate the change? Well, we can see here that this is increasing from 11 to 11, almost 11.5. From 2009 to 2010, it's going from close to 11.5 to about 12.4. And over here we can see 2010 to 2011 is a shorter increase, and the same thing from 2011 to 2012. So if we take a look at the increase, the tuition increase the most was from 2009 to 2010, which is approximately 1,000. So if you take a look here, if we look at this as approximately 12.4, and this is approximately 11.4. So let's take a look here. This represents 11.4. This represents 12.4 thousand. So let's go ahead and do the math here. So we have 12.4 minus 11.4 gives us 1.0, and that's how we're getting our 1,000. In Part D, it says estimate the change in tuition from 2008 to 2012. So let's take a look at 2008 and 2012. So for 2008, we can see that we have 11.0. In 2012, we have 13.0. So if we take our 13.0 and subtract 11.0, then we end up with 2,000. The next question states, what would be the tuition in 2016? Well, if we take a look at the graph here, we don't have a 2016, but we're going to use this to estimate that. So what we found in the first part, it says if the same change occurred, the same change meaning that from 2008, so from 4 years, 2008 to 2012, it increased 2,000. So if the same change occurred from 2012 to 2016, well, the tuition is going to be, okay, well, you're going to take 13.0 and you're going to add 2.0, and that's going to give you the 15,000. And then the last question says, how sure are you that your result will turn out to be true? Well, we're not at all sure that this would be the case because we're estimating.